Okay, for today, you'll need a periodic table. Everybody has one?
Yep.
All right. You'll need like your phone or something as a calculator, but not to use for anything else. Okay, we're going to continue on today with something. As you know, when scientists are looking for something and you want to determine what the components are of a particular compound, you need to know how much of it is there. I want to go back and look a little bit more at understanding, if you have understanding. If I have calcium, can you see that up there? If I have calcium acetate, like so, does everyone know how to count the elements in there?
Yeah.
All right. So we would say in this one we have calcium, carbon, hydrogen, and oxygen, correct? How many calcium do we have? One. How many carbon? Four. 2 times 2. How many hydrogen?
6.
And how many oxygen? Good job. All right, because we have that, now that means that we have, to every 1 atom of calcium, we have 4 carbon. To every 1 atom of calcium, we have 6 hydrogen and 4 oxygen. Yes? We can even go as so far to say that if I have 1 mole of calcium, I need to make calcium acetate. I need 4 moles of carbon, 6 moles of hydrogen, and 4 moles of oxygen. Does that make sense? Because we can equate it. We've already done the massing. We know that 1 mole in 1 atom have an equitable value when it comes to defining the mass of it, correct? We have either AMUs or we have grams. So that's equitable. So the same thing here, 1 mole, 1 mole. Let's use that as a premise. Now, we know that calcium, if we look on a periodic table, we can determine the average atomic weight, which is
40.078.
Okay. Carbon, 12.0107. Is that close? Yes, it is. 1.00794. And oxygen, of course, is 15.9994. All right. Can someone quickly, somebody take calcium, group take calcium. Mal, do you have a calculator?
Me? Yeah.
Okay, you do carbon. Who else has a
I do.
You got oxygen? Who has hydrogen?
I got it.
Okay, all right. Give you a few seconds. For those of you who are watching the video, you can determine this. Wait a minute. Do I really need one for calcium? No. Mrs. Wells. Okay. How about the carbon? Who did carbon?
Me.
Okay, what'd you get?
48.0428.
28 like that?
Yep.
Okay. Hydrogen?
6.04764.
6.04.
761.
All right. And oxygen?
63.9976.
Like so? All right, thank you. Now, everybody understands this. Now, what do we do here? To find the molar mass, or even the atomic mass of this, or the molecular mass of this, what do we do? Add them together. Don't make me do this in my head. Can someone do that? And have somebody else double check it, please? I'm guessing around 160, but it's not 160.
158.16604.
That's what I got too.
158.1604?
Yep.
All right. Now, if I label it grams, all of these are grams. I'm thinking of it as 1 mole or whatever. Now, do you understand in everything, we want to know the percentage composition. Now, what does that mean? It's like saying, when you take a test, don't you want to know your percent? All right. The same thing scientists want to know here too is that what is the percentage composition of everything? How much of this compound in mass is calcium? How much of it is carbon of mass? Okay. So in your mind, how am I going to find out percentage composition? What am I going to find out what the percent of calcium is in that particular compound? What do you have to do?
Divide like the number of atoms.
Yep. Thanks, Casey. That's exactly right. So we're going to take each of these divided by the 158.16604. And as I'm doing this, if you can see the numbers, you can start finding out the percentages. Now, remember you're going to get a decimal number. Everybody remember how to change from a decimal to a percent? All right, great. Anyone do the first one yet?
I've got oxygen.
Okay.
40.4622889%.
Okay.
Wait, Mrs. Wells, you don't do them all by 158, like the last.
Oh,
bottom.
shoot. Thank you. Did you do 158?
I don't know.
Okay, we want to do that again. Thanks, Arian, for pointing that out.
Yeah.
That was my boo-boo. Sorry for making you do that over again. What, anybody do any of them? What'd you do?
I did calcium.
Okay.
I got 25.339.1941.789.
Okay. We're going to talk about why we make it. How much?
40.4622889.
Okay. Anybody do carbon? Anyone do carbon?
I can do it. 30.374915.
All right. Hydrogen?
3.8236.021.
All right. Again, we have these large, I don't say large because they're not very large, but we have these numbers that have a lot of digits. Does that make sense?
Yeah.
Mathematically, does in science. Does it make sense? What are we always concerned about with numbers in science? Significant digits. All right. So in here, our rule of thumb in here is going to be 3 significant digits. So the first one, what would it be in significant digits? What would that 25.339191785% be at 3 significant digits? Do we have to move the decimal? Be 25.3. Yes?
Yep.
What's the next one?
30.4.
30.4%. Next one? 3.82%. And the next one? 40.5%. All right. So if I would add these together, would I get 100%?
No.
Why? Because we had to round. So if you add these together, as long as you're close to 40 or to 100%, like if you're at 99.3 or whatever, do you understand what I'm saying? Because of rounding, you might not be able to get exactly 100%, and that's okay. All right, that's because of the math. You have this down? Do you think you could do this? Okay, let's write down the steps real careful. What's the number one thing we did? We counted amounts of each element. Yes or no? Then what do we do?
Times them by their mass.
Okay, we then by the atomic mass. Then what do we do?
Add them together.
Okay, we added them together. And then what's the fourth step? What was the last step we did? We added them together. Pardon me?
Divided.
We divided them. Divided. each elemental mass by the total. Yes?
Mm-hmm.
Okay, and then I'm going to put here to make sure that it's in a percentage form. This process is known as percent composition. We good? All right, there are examples in your book of how this is done. They use different compounds, of course, but there are many examples about this. I just wanted to go through with you with this today. Now, we're going to be utilizing this to determine some other information on how to find formulas. Now, if I gave you what we're going to do next time is we're going to take the percentages and use that information to make formulas. Okay? So I'm going to leave you with that today, and we'll go to part 2 and 3 at a different time.